I'm going to talk about why you don't trust your linter. So a little bit about me. My name is Jeroen Engels. It's a Dutch name. I'm used to people mispronouncing it. I go by JFM Engels pretty much everywhere. I work at a company called Crowdstrike. I work on the Falcon log scale product, which is a very efficient log management system. It was previously known as Humio until like 2 weeks ago. So if you know Humio, it's the same thing. We use Elm on all of the front ends, which I'm working on. If you're interested in that, we're hiring. And in my spare time, I work on a tool called Elm-review, which we will hear about. And I'm the co-host of the Elm-radio podcast. I love Elm, if you didn't know. So before I talk about linters, I want to talk about another technology that I find super useful, and that is Google Maps. Specifically the feature that allows you to, that tells you how to go from point A to point B. And it's super useful. Like I use it all the time. Every time I go to somewhere new, I go into my car, I enter the address, and I follow the directions. Google Maps tells me to take a right turn, to take a left turn. At some point, I arrive at my destination, and I'm super happy. The problem is that sometimes it doesn't work quite that well. So for instance, at some point, Google Maps might tell me to take a right turn. I look on the right side, and there's some road work, and that prevents me from entering that street. So that's annoying. I can understand why Google doesn't know about this temporary thing, but the problem is like there are some directions that I want to follow, and I can't do that. So what I'm going to have to do is to ignore Google Maps. It sucks, but that's pretty much the only option I have, right? Because I can't follow the directions. So I'm just going to continue forward or something, and then hope for some better directions. So I do that, and at some point Google Maps tells me to take a right turn again. And the problem here this time is that this is a one-way street, if I look to the right side. But it's a one-way street that goes in the opposite direction. And here's a bit weird, because I would have expected Google Maps to know that it would be a one-way street. So I'm curious, like, why did it not know that? But also really don't care at the moment, because my focus is on getting to my destination. All right, so yeah, I'm gonna have to ignore Google Maps again. So I continue forward, and I hope for some better directions. At which point, Google Maps tells me to turn around and enter the one-way street again. And that's quite annoying, because at this point, Google Maps doesn't help me at all anymore. And basically, like, whatever directions it's giving me, they're not useful. So I might as well turn Google Maps off. So this doesn't happen quite often, thankfully, because otherwise no one would use it. But it does happen sometimes. And because we've been in these situations, or at least I do, I allow myself to second guess the tool. So for instance, if I'm driving and Google Maps tells me that there's some congestion up ahead and to take another road that would be faster, then I'll be always wondering, like, should I take the advice or should I ignore it? And that's not something that I want to do, right? Because there's a tool that is here to help me to make the decisions in my stead, and I'm still making the decisions because I know it's been wrong before, and that is not perfect. And the same thing happens, in my opinion, for linters. Sorry. So linters are a static analysis tool. They look at your code, and basically they're trying to find problems without executing the code. So yeah, they look at your code. They don't try to execute it. They're going to try to find problems like programming errors, improvable code size issues, those kinds of things. So they're the origin of all these squiggly lines that you see in your editor, along with compilers. And I'm pretty sure that everyone here uses one. Who doesn't use a linter? Okay, one person who's a language author. So yeah, I think that everyone should use one. There's one for at least every language, at least one for every language. And they're super useful. The problem is that sometimes they don't work. So my claim today is that you don't trust your linter. And I'm not someone who really likes to make claims, But I feel like this one, I'm allowed to. Like, I have some data. Because I know that just like I ignore Google Maps sometimes, you also ignore the tool. And there's quite a telltale sign that you do ignore it. So these are called disable comments. So whenever your linter reports an issue and you don't agree with it, you add a disable comment and the linter stops showing it. So trust is a notion that I've only been considering recently. Like, I've been using these linters for years. I've been working on them for years. And it's only recently that I've come to appreciate the fact that we can do something about it. I always thought, oh, well, the linter is wrong. Well, not much we can do about it. Well, turns out that there are things that we can do about it. So a few years ago, it actually just turned 3, I started working on Elm-review, which is a static analysis tool for the Elm language. If you don't know Elm, go try it out. You're going to learn a lot of things. If you do know it, we're hiring. So this is what Elm-review reports look like. They're very friendly. So it's a tool that I find very useful, that I trust. Not a big surprise because I made it, but other people also like it and they also trust it, and that makes me very happy. So we're going to learn why this tool is trustworthy, whereas some other tools are not. So we're going to talk about false positives, we're going to talk about communication, automatic fixes, configuration, and ignoring reports. So let's talk about false positives. So that is when the tool reports an issue that it shouldn't have. So that is the main reason why people don't like linters, because they report too many false positives. I have heard of linters that report like 90% of false positives, at which point you're like, why should I even care about the reports, because they're always wrong? Why should I spend so much time fixing those issues? And you would be right, I wouldn't. So a lot of people actually do stop using linters because they're too annoying. So false positives, they cause you to lose trust in the tool. So trust is a spectrum, where on one end, you absolutely love the tool, you trust it, and on the other hand, you hate it, and you're wondering why your teammates still want to use it. So just like Google Maps, sometimes the tool is going to give you some directions, give you some reports that turn out to be wrong. And just like Google Maps, when the first time it said something to me that was wrong, I was like, the tool is not as good as I thought it was. It's not that trustworthy. So I lose a little bit of trust. And the more that it reports issues that are not true, the less I'm going to trust it. So it's obviously not going to happen in 3 steps, but you get the gist. And for linters, every time that you encounter a false positive, you're also going to add a disable comment, because you don't want to hear about those false reports again. And these disable comments have a very bad side effect in the fact that they change how you think. So whenever you encounter an issue, the healthy way of thinking is, how should I fix this issue? Like, something has been brought to your attention, something is wrong, how should I fix it? But the problem is that the more that you see these disable comments, the more that you encounter them, the more you use them, the more you get trained into using them, because it's normal, right? So the more you use them, the more you're going to ask yourself, should I ignore these reports? Which is absolutely, in my opinion, a bad way of thinking about it. So if you say, no, I'm not going to ignore it, then you ask yourself, how should I fix this issue? And if it's too hard, then you got to ask yourself, should I ignore these reports anyway? So this is not something that we want to, a state that we want to be in. Okay, let's talk about what causes false positives. So the first thing that causes false positives is bugs, because linters are just like any other software, they're buggy. The good thing with these is that they tend to disappear. You open an issue, the maintainer sees it, they fix the issue, and they cut a new release. Goon, the bug is gone. The problem is when the bug is not easily fixable. So that, in my opinion, very comes down to missing information. So the way I see it, I like to imagine a linter that is omniscient, that has all the knowledge of everything. For instance, it knows every line of code in your code base. It knows how that code will execute on a machine. And it even knows how what happens in the developer's minds who wrote the code. So it's like really powerful. And I can't imagine that this tool would ever be wrong. I can't imagine that it would ever say, this line of code here, there's an issue when there isn't. Or say, this line of code here is okay when there is an issue. So in my opinion, false positives, they always come down to missing information. And unfortunately, that is what we do in the real world, because we don't have missing we do have missing information. Our linters are unfortunately not that powerful. So what do we do when we have this? Well, we make presumptions. So that is saying like, well, I don't know whether this thing is true because I don't have this necessary information, but because I know that in 95% of cases, this thing here, whatever that might be, is true. So let's accept that, and that will work in 95% of the cases. The problem is when you enter those 5%, or 10%, or 1%, whatever it might be, when the presumption turns out to be wrong, that's when you get a false positive or a false negative. So false negative is when the tool doesn't report an issue when it should have. These are less annoying because they don't block you and you don't notice them, but they're bad as well. So one way we can fix this is by providing more information. So the ESLint static analysis tool, which is the de facto linter for JavaScript, when it looks at JavaScript files, it looks at them individually, one at a time, meaning that it looks at one file and it doesn't have access to all the other files. And that is quite limiting because there's a lot of information that we can't gather. So for instance, if your JavaScript file imports another file, you might want to know what functions are available, but you don't have that information because you're only looking at a single file. So what you can do is to fix this issue is you can provide more information. For instance, in this case, you could provide the contents of all the files of the project, not just that single JavaScript file. And that means that you could have a lot more information that would make the rule a lot more powerful, and that would make the rule a lot more precise. So linters are made of rules in general. One rule checking for one specific issue. Other kinds of information that we can give is type information. That is also always useful. We can give access to dependencies, what is available from dependencies, which modules, which functions, or even how the code was written. And we can give access to files from different languages. Like a JavaScript linter might still want to have access to CSS files because they tend to work together. So that can be very useful. So this is something that tooling authors have some power on, some control over. And this is a direction that I'm going with Elm-review, where I'm just providing more information and making it easy to get that information. And so far, it looks very promising. Things do get more powerful, and we get less false reports. So another aspect, which tooling authors don't have control over, is how easy is it to analyze a language. So languages have different kinds of features, or they're built in different ways. And some of them make analysis a lot easier. Some of them make analysis a lot harder. So for instance, compiled languages, they make things easier. We get a lot more information from them. We know that this thing holds true, this thing is always true when the code compiles. Statically typed languages, they also make the code a lot more easy to analyze when code uses explicit patterns as well. And what makes things harder is like dynamic constructs. For instance, being able to call a specific function based on the value of a string, those kinds of things. And a lot of other things, but yeah. So Elm is on the green side, where everything is compiled and is statically typed. And therefore, it's a very easy language to analyze. Therefore, we have a lot more a lot less false positives and false negatives. JavaScript, on the other hand, is very dynamic and therefore very hard to analyze. So I'm not going to go into more details about this because I already made a whole talk. It's called Static Analysis Tools of PureFP. If you're interested, I will have the link at the end. So now let's talk about effective false positives. So those are not false positives. Those are true positives. When people see them, they think they're false positives. So very often that is down to how the error is communicated. So for instance, let's say I just run my linter and I get this error report. We have some information here. We have the file path, we have the location, we have the message saying don't use native buttons, and we have the name of the rule that is no native button. So this is very useful to have, because I know there's an issue and I need to address it. The problem is that this is not sufficient for me to fix the issue. For instance, I might not know what a native button is. Maybe I'm a junior, maybe this is a new language to me, new concept. I might know what a native button is, but I might not know why we don't like them, because I use them in other projects and they were fine there. And also, like, what should I do instead of using native buttons? I don't know. So this is not sufficient. So in my opinion, developers, they need to understand at least three things. One, what they did wrong. If they don't understand why something is being reported, they're going to try to debug the tool, and nobody wants to do that. Two, they need to understand why it is a problem. If they don't understand why we're trying to report this issue, they're going to be frustrated. They're going to think the rule is stupid, and they're going to curse all over the office. And three, they need to understand how to move forward. Like, what is the intended solution to this problem? And when they don't understand one of these three things, they're going to use workarounds. So very often that is in the shape of using a disable comment like this. Another workaround would be to change the code in such a weird way that the linter is not smart enough to detect the problem. And in both cases, the code just got worse, and we still have the initial problem. So this is absolutely not something we want to end up with. So let's try again giving a better error message. So this is what an Elm-review error would look like. So we have the same information. We have the file path and location, we have the name of the rule, and we have a message, which we've changed to something that's a little bit more helpful. Use UI button instead of the native HTML button. We also give a source code extract showing like where the problem is. That is quite useful to have a visual indication and to see, oh, okay, yeah, this is the problem, I understand it. But this is not sufficient again, right? We're still not answering the three pieces of information, the three questions that we asked ourselves before. So we give more text, we give more information. For instance, we give the context, which reads, at Fruiters.com, we try to have a consistent UI across the application, and one of the ways that we do that is by having a single nice module to create buttons, named UI.button. Okay, now I understand why this is getting reported. Okay. We give the problem. Here, you define the UI button using HTML button, which is likely not to have the consistent UI we aim for, or some of the guarantees we created around buttons. Okay, now I understand what I did wrong. We give a suggestion. Instead, you should use the UI button module. I suggest reading the documentation in that module, where here's what it would kind of look like, and we give an example. So now we know how to fix the issue. We have all the necessary information to not disregard the reports. And the problem is that most linters, they only allow you to give a one-line error message. So only this thing at the top. And that is not sufficient information, in my opinion, to convey all the necessary information. You get it. So you might think that this is a lot of text, and I agree that this example is quite verbose. But in practice, I think it's absolutely worth it to add all that information, because people won't just disregard the error. And sure, it might take a bit of space in the terminal, but people are just going to ignore the context, the details, if they've already read them and they understand the problem. So just going to take some space, but it's absolutely worth it in the end. So now let's talk about automatic fixes. So automatic fixes are people's favorite feature in Linters, because the Linter is going to report issues, but it's also going to fix it right away. So, the problem is that these can be done in more or less trustworthy ways. So here, I just ran eslint --fix on a project of mine. And I've got a very big diff of 600 lines, which I consider to be quite big. I will talk about a few times about eslint. It's a great tool, just I'm not trying to bash it. It's just the one that I know best. So the problem with the eslint fix is that it doesn't show me all the errors that were reported. It will just run the analysis and fix all the ones that it can't fix, but it doesn't show any information about those issues. So, I'm going to run it, and I don't know what issues were reported. I don't know why they were reported, and I don't know how the tool tried to fix those issues. And because I don't know how it fixed those issues, well, I don't know if these changes are safe. I also don't know whether this code can now be sent to production. So here I have three options. One, I go through the whole diff, like this. Yeah, but because it's a fix all or nothing approach. So one option is I go through the whole diff. It's fine if it's small. If it's like 600 lines, maybe it's going to start to be quite annoying. So that's going to be annoying. A second option is to not use eslint fix and just to go through all the errors one by one myself, which I don't want to do because there is an automatic fix. And the third one is to just blindly accept this whole diff, which I wouldn't say is trusting, because I haven't looked at it. I would say that is more submitting to the tool. So that's not something that I want to do. So what Elm-review does instead is it prompts for fixes. So when you run Elm-review --fix, it will go through errors one at a time, and for every error, it will show you all the details that are very useful, as we've seen before, and it will tell you, hey, I think I can fix this. Here's my proposal. Here's a proposal just to delete the entire function because it's an unused function. Do you wish to apply this fix? Yes or no? If I say yes, it's going to apply the fix. If I say no, it's going to ignore it. And in both cases, it's going to go to the next one. So the nice thing with this is that I can see what errors were being reported. And I can also see how the tool tried to fix those issues. So it's very transparent about how it tries to do it. And this is, in my opinion, how you gain trust, by correctly and transparently doing the right thing over and over again. So if you see that this fix is correct, if it's the right approach, then you're going to trust the tool. And if you see that it does it over and over again, you're going to say, okay, well, it's always good. I can just almost blindly accept it. At which point, that's where I would recommend using Elm-review --fix all, which fixes all the issues and then prompts for one big giant diff at the end. Yeah. So now let's talk about configuring linters. So in my opinion, there's two kinds of configuration. There's essential configuration and accidental configuration, just like accidental and essential complexity. Let's start with the second one. So accidental configuration is when you tell the tool how to work with your project, because it can't figure out some information on its own. Like, it needs to know some things, but it doesn't have any way of getting that information. So for instance, that might be which language features are enabled or available in your language. Which version of JavaScript are you using? Are you using ES 2015 or using ES 2022? Because that might change how the rules will behave. Some might make some presumptions when they don't have that information. Also, what tools does this project work with? Are there any build tools or macros that will change how the code behave in a unexpected or non-standard way. And when you misconfigure this configuration, that's when you have false positives because of the configuration. So one way that you can notice that it's due to the configuration is when a maintainer tells you. So you open an issue, you say, hey, I've got this false positive. They ask you, like, can you share your configuration? You show it, and they say, oh, that's not a false positive. That's because you misconfigured the tool. Which, yeah, that's fair. But to me, it still feels like a false positive. So in practice, it's an effective false positive. And I don't have any feedback loop to tell me that I misconfigured the tool, except by going on Stack Overflow or opening an issue for the maintainer. So accidental configuration, we should try to avoid as much as possible. But that's somewhat hard. So in Elm, one of the things that we care about is which version of Elm are you using? Are you using 0.19 or 0.18? And thankfully, that information is available in a standard file. It's in the elm.json, which every Elm project has needs to have. So all the necessary, because all the necessary information is in standard files, either in Elm.json or in other files, we don't have any accidental configuration. We don't need to ask the user to configure the tool for the tool to understand the project. So then there's essential configuration. So that is when you tell the tool what you want from it. So that's likely what you thought about when I said, hey, let's talk about configuration. So that is, for Linter, what rules do you want to enable and with which options? So in the case of Elm-review, because we don't have any accidental configuration, the only configuration we have is just the list of rules that you want to enable. So I want to enable no bad thing and no other bad thing with some option. So one advice as a user that I would give to you is that you should enable rules that you agree with, which sounds a bit obvious, because when you get when you get a report by one of those rules, if you disagree with it, then it really sounds like a false positive, so an effective false positive, because the line between the rule is wrong, the tool is wrong, and I disagree with it is very, very thin. So only enable rules that you agree with. So some advice on that. Whenever you add a rule, you should always get your team's approval. Because if someone on the team disagrees with one of the rules that you add, then they have a rule that they don't agree with. And they're going to be frustrated, they're going to curse, they're going to make everyone's day worse today. You should also understand that not all rules are good. There's a bias to think, well, if someone wrote this thing, then it must be good. Someone must have thought it through. And in practice, that's not always true. Some things are not good. And therefore, you should always try to understand the problem well. There were cases where I thought, well, I don't know what this rule exactly does, but I think it does something quite useful, so let's enable it. And that in the end just reported issues that I disagree with. So you should always be ready to disable a rule if it ever feels painful. If it's starting to report false positives or effective false positives, then disable it. Or in some cases, real false positives. And if you don't want to enable rules that you don't agree with, you should not use other people's configuration. At least in the JavaScript community, because there's a lot of rules, people tend to take someone else's configuration, and they get bitten by that because it doesn't do what they want. So, ignoring reports. So, linters, they tend to have two main mechanisms for ignoring reports. One of them is disable comms. We've seen them before. I think that they're a bad solution to all the problems we've seen so far. So I don't like them. Another system is severity levels, which is basically configuring your rules to be either an error or warning. Those are the two more common ones. So errors, they will cause your tool to crash whenever they report an error. So that will make your test fail. So you want to use those for rules that you want to enforce. Warnings, they will not cause the tool to exit with an error code. So you want to use those for rules that you want to enforce. No, for rules that you don't want to enforce. So you enable those rules, but you don't want to enforce. To me that doesn't make sense. Like you enable rules to. It doesn't make sense. Even if it does make sense to you, they don't work because those warnings tend to pile up. So imagine I have 2 warnings at the moment, and a third one shows up. Well, you notice it because you only have 2 or 3. Now you ask yourself the question, should I fix this issue or not? Because it's not enforced. You have the choice. But as I said before, should I fix this issue is not the right approach to have. The right approach is, how should I fix this issue? So if you do decide not to fix it, that is going to add up to this list of warnings. And at some point, you're going to end up with a wall of warnings. So now let's imagine you have 100 warnings, and you and 5 new ones show up. Well, you won't notice them. So you're trying to enforce some rule, but you won't notice the new issues. So yeah, that doesn't work. So all of these linters that have these mechanisms, they have some documentation on how to use those. But when it comes to advice or guidance on how to use them, I have yet to find a single linter that gives any advice on these. A single linter that says, this is when it makes sense to use a disable comment. This is when it doesn't make sense to use the disable comment. This is when it makes sense to use an error severity level. This is when it makes sense to use warning. And I found that very weird that they don't give any advice because, for instance, disable comments are a very risky move. Imagine you have a linter that tells you, hey, this code here, this code will crash. And someone looks at it and for some reason doesn't understand it, doesn't want to tackle it, so they added disable comments. Well, that's pretty scary to me. I don't know if it's for you. So I don't know why linters don't give any advice on this. In my opinion, it's probably because they don't know. I think that a lot of linters, they add these 2 features because other linters had them before. So does Elm-review give any advice on how to use these? No. But for a good reason. It's because we don't have them. So Elm-review doesn't have any magic comments that suppress an error. So you can't suppress an error through code. And it doesn't have this system of warnings. So every rule that you enable is enforced. And that might seem a bit scary to you, like, sure, in some cases it makes sense. Well, let's go through them. So one instance where you might want to have these systems is when you have rules with exceptions. So for instance, you might have a rule that says that reports an issue, and you're going to look at it and you're going to be like, yep, that's an error. That's an error. We should fix it right now. And the same rule might tell you, hey, there's this error. And you're like, yeah, no, that one is fine to ignore. So the human makes a decision about whether or not we should fix this issue. And I found that a bit weird because just like Google Maps, now the human is making the decision. And that should be the linter's role. So apparently the human has some kind of heuristic about when it is okay, when we should fix it and when it is okay to ignore. And I would say that you should take this heuristic and put it into the rule. And that means that your rules will have to be higher quality. They will need to do more work. They will need to be maybe slightly more opinionated, who knows. But in practice, it's going to be beneficial to everyone because the human will not have to think about, should I ignore this report anymore? The tool will do it for them. And in some cases, you are not going to be able to figure out what that heuristic is. You're not going to be able to differentiate between false positives and true positives. In those cases, in some cases, it makes sense to not write the rule. Because in a lot of cases, the rule doesn't matter all that much. If it's for a critical issue, like this code will crash, then yeah, it makes sense. But for all the other ones, like code style issues, or let's try to find a way to improve this code, but we don't know when it's a true positive and a false positive, like maybe it doesn't matter in practice. So these are two things that we do with Elm-review. We either write high quality rules that are thought through, that have thought about all the edge cases that we can have, or we don't write the rule. And in practice, that's okay. So in my opinion, when you have disable comments and warnings, they enable bad quality rules. They enable rules that have not been thought through. Because, oh, well, yeah, in some cases it will report a false positive, but we can just add a disable comment, right? Doesn't matter. So in some cases, you will want to ignore the rule because in some places it won't make sense. So for instance, let's say that in tests, we don't care about unused variables or we don't care about debug logs. So what you can do is in your configuration, you'll say, well, ignore these two rules for tests. And the nice thing with this is that all the exceptions will be in your configuration. They won't be in your configuration and spread all over the application between warnings and things that are disabled. So you only have one single place to look at. So another case is when you want to allow existing errors. For instance, if you want to gradually adopt a rule. So you found a rule that will be very useful, but the problem is that it is currently reporting a lot of issues. One such instance is when you want to deprecate a function. So let's imagine we have some function which has been marked as deprecated because we have some better function to do the same thing. So we don't want some function to be used anymore, but it would take too much time to fix all of those. It would take weeks of work. So let's do it later. But we still want to be notified every time someone tries to use it. So we have, this would report this kind of issue in the Elm-review. Hey, you're using some function. It was marked as deprecated. Yeah, don't use it anymore. So one option that we can do is we can add disable comments everywhere. So let's imagine you have 1,000 problems with this. Well, now you have 1,000 disable comments. It's possible, not what I would recommend. It's not going to make your code prettier, that's for sure. Another thing that you can do is to enable the rule as a warning. But if you have 1,000 errors, well, now you have a wall of 1,000 warnings, meaning that every new usage of some function that you find, well, it's going to be reported, but you're not going to notice them. So that's not going to work. So what we do in Elm-review is we have a suppression system. Basically, what you do is you run Elm-review suppress, and it's going to analyze the project, and for every rule that is currently reporting issues, it's going to create one such JSON file in the review configuration, because the configuration is a folder in Elm-review. And basically, for what it's going to do is, what the data is going to contain is, for every file that is currently reporting an issue, like source API, it's going to count how many issues there are. In this case, 7. So what happens if you run Elm-review suppress, that you get all those JSON files, and then you run Elm-review again? Well, because you're not going to have any new errors, it's going to say, I found no errors. You still have, like, there were 7 issues that I suppressed, and you should go fix them at some point, but you can continue working. Nothing is, there were no new problems. What happens if you introduce a new issue? So if you go from, you introduce a new usage of some function, so you had 7 before, and now you have 8. Well, Elm-review is now going to say, hey, there were 7 issues, there are now 8. You need to fix some of them. Like it's going to show all the suppressed errors and the new one. because it doesn't know which ones were old, which ones are new, because we don't use Git as a source of truth. But basically, it's going to say, you should fix at least as many so that you go back to count to 7. So every new usage, every new problem, you will be notified, and that's what we want. What happens if instead of introducing a new one, you fix one? So you go from 7 to 6. Well, then again, Elm-review is going to say, everything's fine. And by the way, thank you for fixing one. And it's going to automatically update that JSON file. So we'll say, instead of saying count 7, it will say count 6. Meaning that if you introduce a new one, you go back to 7, then it's going to say, hey, you introduced a new issue. So it's trying to do the right thing to, what we want to push towards is people fixing issues. And we want to make that easy. And we want to make it harder to do the bad thing, which is introducing new issues. So, to summarize, we've seen that false positives and effective false positives, they lead you to losing trust in the tool. That we can remove false reports by providing more information. That is something that tooling authors have power on. That communication is very important. People need to understand what is the problem, why is it a problem, and how to solve the problem. That we should avoid accidental configuration as much as possible. That does require a healthy and law-abiding ecosystem, in my opinion, so that's very hard to do, but it can work some cases. People should only enable rules that they agree with, that there are better alternatives than disable comments and warnings to ensure that rules are enforced. That has worked super well for Elm-review. And we've seen that tools can only gain trust by correctly and transparently doing the tasks over and over again. It is really easy to lose trust. It is really hard to regain it. So if you thought that any of my points were interesting or good today, I would really hope that you open issues in your linters to improve them. Say, hey, it would be good to have more details in linter errors, stuff like that. So that's what I hope that you will do after this talk. Thank you very much.